Hello, the sum that we're going to be solving today is minimum cost climbing stairs. Let's read the problem. You are given an integer array cost where cost at I is the cost of ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from step 0 or from step 1. Return the minimum cost to reach the top of the floor. The example that is given here is 10, 15, and 20. 10, 15, and 20. That means I have some steps and I want to reach the top. The cost of taking this step is 15, 10, 15, and 20. I can either start from here or I can start from here. I can either take 2 steps or I can take 1 step. So, to the naked eye, this is very clear that we can directly start from here, take 2 steps and reach the top. So our minimum cost would be 15, because if I take this step, go here, then go to the top, then my cost would be 30, right? So basically the decision tree would somewhat look like I am taking index 0, 1, 2, 3. I am taking index 0, or I am starting from index 1. From index 0, I can either go to index 1 or I can go to index 2. From index 1, I can either go to index 2 or I can directly reach the top. Right? I can directly reach the top. So basically, what we're trying to return, you need to understand what the recursive function would look like. What would the recursive function signify? The recursive function would signify this, that recursive function would signify this, that the cost that we're gonna take to reach that particular place, right? So if here, to reach here, what is the cost that I took? What is now from here also, there obviously will be a top, so from here I have reached the top, taking 1 step to reach the top, right? So I will be returning the cost it took me to reach the top, right? Cost it took me to reach the top. And similarly, so if I reach here, right? So when I reach the top, when I took this step, so this should return me 15. This should return me 0, because from the top I cannot go anywhere. So this should return to me 0. And since I took this step to reach the top, I took 20. So the minimum of 20 and 10, 0 is 0. So here, from here, I will be returning from 1, I will be returning 15, because I took that step. Plus I added the next step, that was 0. I return 15. From here, what is happening? From here, I return 0. From here, both the options would be top. So like 1 step and 2 step. So both will be returning 0. So the minimum is 0. I returned a 0. From here, again I returned a 0. No, from here I returned 20. Because this is 0, I returned 20, because 20 plus 0. Because I took this step to go here and here. I took this step. So from here I returned 0, and from here also I returned 0. So here it would have to take the decision, what was the minimum of 20 and 0? What was the minimum of these 2 trees? The minimum was 0. So I returned the cost of taking this step, 15 plus 0. The cost of taking this step was 15 plus 0, which I took. I returned 15. From here I returned 0, because obviously there was no other option from 2. So I took this step, so I returned 20 plus 0. So what is the minimum of 20 and 15? It is 15. So from here I returned 15, plus I took this step, so I returned 15 plus 10, I return 25. So what is the minimum of these two? My answer is 15. So that is how the decision tree is gonna work. So let me just code up the brute force for you. It is pretty simple and straightforward. I'm just gonna return math.min. I'm just gonna return math.min of solve of I of 0 comma cost and solve of 1 comma cost. This is the decision that I'm gonna be making. Then my function would somewhat look like solve int I int array cost return cost of I, the cost of taking that step, plus the minimum of taking the next two steps, I plus 2 cost. What would our base case be? Our base case be, since we are climbing upstairs, if my I is equal to nums dot length minus 1, nums dot length minus 1, then I would be returning nums cost at I. I would be returning cost at I. This is cost. And if my I is greater than equal to nums dot length, why am I writing nums dot length, I'll be returning a 0. That means we've reached the top. So when I run this test case, these test case should be accepted, but this is not how this works. This is not the optimal solution, right? This is not the optimal solution at all, because when we sit and draw this for the second example, this big thing, the time complexity would go to 2 to the power n. We do not want, this is a pathetic time complexity to have. So we do not want this. So if you notice here, we are doing we are doing this repeated tasks. All of these are repeated tasks. I want to minimize this. There is where DP comes into picture. That is exactly where DP comes into picture. So here essentially what I am trying to do is I'm using a bottom up approach. That means, or to make it simple, I can also start from down, the top down approach. This is top down, this is bottom up. No. This is top down, bottom up. Okay, anyways. No, this is a bottom up approach, because we're starting from the bottom to the top, and this is a top down approach. My god, I made a blunder, I am sorry. Anyways, so here what we're gonna be doing is that we can start from this. We can either start from this or we can start from this, right? We can start from any of these two. So we're going to be filling the DP table with the values of these places only, right? Now, what is the decision that I'm going to take? Which step should I take? The step for this, for reaching here, which step should I take? I can reach here from this also, I can reach here from this also. That is the sub problem. So like, if my problem was just this, my sub problem, my main problem would just be reaching here, right? So there are only two ways. I can reach from here or I can reach from here. But which step am I going to take? I need minimum. So I'm going to take the minimum of these two. I'm going to take minimum of these two. So essentially our dp function would just be dp at I is equal to math.min of dp at I plus 1 comma dp at I plus 2 dp at I plus 2 plus cost of I. Why cost of I? Because I'm gonna take that step. If I'm reaching that step, I'm gonna take that step, right? So basically the minimum of these two plus 1 is 1 plus 1 2. Then I'll calculate for this. The minimum of these two plus the minimum of these two plus this is 3 Then the minimum of these two plus this is again 3. Then the minimum of these two plus this is 103 4 5 105 104 and 6 and essentially what we're gonna be finally, our answer is the minimum of these two, because if you see, like in this example, this is greater than this, but what if it was the other way around? Some reason, due to some calculation made our dp table like this, then of course our decision would be to take 2 steps from here to reach the top, because this is the minimum. So let's quickly code this up. Int n is equal to, why am I writing nums? Cost.length int dp is equal to new int n. dp at 0 is equal to cost at 0. dp at 1 is equal to cost at 1. For int I is equal to 2, or int I is equal to 2, I is less than n, I plus plus dp at I is equal to cost at I plus math.min of dp at I minus 1 comma dp at I minus 2. I just realized I mistakenly wrote plus here instead of minus. That is my bad. We are writing minus because we are checking for the last the cost of taking the last 2 steps, right? So this, and finally we are going to be returning math.min of dp of n minus 1 comma dp of n minus 2. Hopefully this gets accepted, and my test cases are accepted. I hit submit, and there you go. My solution has been accepted. I hope you all understood all of this, and I hope you all have a great day.